Hello, in today's tutorial we will be dealing with socket programming. This is the lab 2 of E542. Let's upload the NS file to start off with. So the NS file is simple for this experiment. It's just creating two nodes, node A and node B, connected to a full duplex link, and so we have saved the client and server codes of the socket programming as .exe file, and we'll be installing them as a tarball file in both node A and node B in user/hash directory. So let's swap it immediately. And today's main objective will be creating a stream socket and then a UDP Telegram socket, as well as multiple clients trying to access the server. So let's wait for it to swap. Yep, it's swapped in. And let's check the visualization tab to verify that we have the correct topology. So yeah, as expected, we have node A connected with node B in a full duplex link. And yep. So let's now try to go through the server code. So the server code is just a socket. We have a simple socket descriptor with this stream socket configuration, and then we bind it with the port number. We bind the socket with the port number, which will be given in the command line, and then we use the listen and accept functions to accept connection and listen data onto the port number. Now let's take a look at the client code. The client code is simple as well. It's another stream socket, and we'll be using the connect function to connect to the port number of the server, and read and write functions to take input from the command line and push it onto the server. So let's use putty and access node A, which will be the client for this program, and node B, where we can run in the server program. So enter my login USC542DU. Every time we enter it asks for a password, and let's now SSH into node A. Sorry about that. Node A dot socket test dot ee542, which is the qualified name, and enter yes. And now we are successfully connected to node A. So let me change directory to user/hash, and yeah, we have the client.exe file, which means that the tarball file has been installed successfully. Now let's connect to the node B. So we have to repeat the same steps, but SSH into the node B using the node B's qualified name. Yes, yeah, now we are successfully connected to node B. Let's change directory to user hash. Let's check for the server file. Yep, so the tar file has been successfully installed. So we have got the executable server file. Now let's go ahead and execute the server file. That will be ./server dot port number. Oh, sorry, I missed the .exe. Sorry for the typo. So it should be .server dot .exe space the port number, which will be 25,000 here, and then click on enter. And now the server code is running in node B. Node B is acting as the server. And now on the node A, let's execute the client code with this ID being node B, which is where the connect function will connect to, and the specified port number 25,000. Let's enter the message, and as you can see, the socket is successfully installed and the communication went through. So let's go on to the next phase of the lab. So I have an executable file in the directory proj/e542. So next part of the program is to make the server run indefinitely. So in this case, after the message is received, the server has stopped working, but in a real life scenario the server runs indefinitely. So the code is modified in such a way that the listen and accept function are running it within an infinite loop with no conditions and no breakpoints. And that file, I'm gonna execute that file with the port number 25001. And, oh sorry, it is server_mod. That's the file for the server to run indefinitely. So I can't use 25001 again. So yeah, the port number 25002. The server is now running. Now I'm running the client. Yeah, and you can see that the server doesn't stop. We put another message, and yeah, so the server now is running indefinitely. And let me stop it. And now to the next part of the experiment is to perform and run a UDP datagram socket. So the UDP datagram client executable file is in the directory /proj/e542, same as with the server. Let me get it. So it is under the name client_UDP, so you can see there. And for server it is server_UDP. So the only change here is that the socket descriptor has a datagram sock value within the function. So let me run the UDP server code with port number 25003. I missed the .exe there. Now the server is up and running. We run the client code for the datagram socket. It is client_udp.exe. space 2503. So here the target is again node B, and in this case the code given in the manual demands you to enter the full qualified name of the server. So that would be nodeb.socktest.ee542.isi.interlab.net space the port number, which will be 25003. So yeah, I'll have enter the message, and server has received. So now let's get to the next part of the experiment, where we have to create two clients and a server. So here is the NS file that creates one more node C, and then it sets up a link between node B and node C, node A and node B earlier. So node B will be the server, with node A and node C being the clients. So let's wait for it to work. So yeah, now the NS file has been executed, and we can see that the topology is changed, with node B being the server and node A and node C being the clients. So let's access node A and then try to run the client code in that, and the server code in node B and the client code again in node C, and try and check that node B is able to receive messages from both node A and node C. So right now I'm switching into node A. We change directories to the location where I have the client code. Yeah, that's done. Let me SSH into node B. So yeah, it's done as well. Let me change directory to lodge/e542 so that we can run the server code that makes the server run indefinitely. ./server_mod.exe, port number 25444. So now let's access node C. Directory. So changing directory to user/hash and executing the client code. Executing the client code in node C, the port number 25444. Let me enter the message, and you can see that the server has received the message successfully from node C. Now let's execute the client code from node A. 25444 port number, and send the message, and yeah, so you can clearly see that node A is also successfully able to send the message to the server, and that wraps up lab 2 of socket programming. Thank you for listening.